Picture this. You're at a Formula One race. The car screams into the pit lane. The crew is totally ready. Every single mechanic knows exactly what to do. But if just one person hesitates for half a second, or if one wheel nut is threaded improperly, the race is literally over. And here's the thing. The team doesn't lose because the car was slow. They lose because the execution broke down under pressure. Well, this explainer isn't just about understanding the underlying math of kinematics. It's about executing a flawless sequence under immense time pressure, where a single tiny slip costs you crucial marks on your Cambridge IGCSE Additional Math 0606 exam. And, let's be honest, possibly a few tears.
So let's kick things off with part 1, the F1 pit stop, focusing on timing and precision.
Okay, let's dive into this. In the high-stakes pressure cooker of an exam hall, timing and precision are absolutely everything. Just like that half-second delay ruins an F1 race, skipping just one procedural step in your Cambridge 0606 kinematics problems will instantly tank your grade boundaries. You see, you're not just being tested on whether you can find the right number at the end. You are being evaluated on the precise sequence of operations you use to get there. Lost marks are rarely from bad math. They're from bad execution. And it's painful, right? Doing all the hard math perfectly and still losing points. So many students walk out of the exam hall feeling incredibly confident, only to get their grades back and realize they lost easy, foundational method marks. Why does this happen? Well, because ordinary revision focuses on calculating, but it completely fails to teach execution.
Before we fix that execution, we need to clearly define the actual challenge. Kinematics in the 0606 syllabus is all about the mathematical relationship between displacement, velocity, and acceleration of a particle moving in a straight line, which we analyze through differentiation and integration. This is your foundation. But the Cambridge syllabus emphasizes that top-performing students don't just memorize formulas. They exhibit a connected conceptual understanding that is completely transferable to these specific variables, whether acceleration is constant or variable.
Now, it turns out there is a powerful examiner clue that changes the answer to these problems completely. It's a fascinating insight into how examiners evaluate your assumptions, and it's exactly what separates the top-tier candidates from everyone else. But, and this is a big but, if you don't have the structural framework in place first, you're never going to spot it.
Moving into part 2, the method mark strategy. This is your quick win. To secure those marks, examiners are desperately looking for evidence of your thinking process. We need to introduce the standardized sequence required to secure these specific method marks. You have to remember, examiners award these for your logical process, not just for that final number sitting at the bottom of the page. Now, what's really interesting here is this bulletproof 5-step methodology. Notice how simple it is, yet how often it gets totally ignored under pressure. 1. Read and extract data. 2. Select your method. 3. Show your steps clearly. 4. Check your accuracy. And 5. Present the final answer. Whenever you approach a multi-stage analysis problem, this sequence is your absolute safety net.
You can remember it with this exact structural flow: deconstruct, extract, select, execute, and present. The academic benchmarks for 0606 require logical, structured reasoning. Higher-order assessment objectives demand this exact analytical depth over superficial breadth. You simply can't just skip from extracting the data to presenting the final answer and expect the examiner to fill in the blanks for you.
All right, part 3, examiner warnings and common pitfalls. Let's raise the stakes a bit. The principal examiner reports expose exactly why students fail kinematics multi-stage analysis. Candidates are constantly, and I mean constantly, losing points on 3 specific traps. Number 1, vague details and a lack of context. Examiners want specific evidence. Number 2, poor format and presentation conventions. And number 3, confusing key terminology. So the crucial point is this. The reports explicitly state that candidates consistently mix up key terms. If you fail to define your terminology before using it in an extended response, you are actively throwing your marks away.
Which brings us to part 4, spot the error, flawed versus top band responses.
I want to challenge you for a second. Think like an examiner and see if you can spot the error in this typical, messy student response on the left before we dig into the optimal methodology. We've got messy calculus, missing units, and totally unexplained steps. You know, the student might have had the right idea in their head, but on paper, it's a disaster. Now compare that to the top band answer on the right. And this brilliantly illustrates the difference. Notice the clear headings. See how the terms are defined before they are used? Look at the highly structured integration and differentiation, and most importantly, the justified steps. This presentation follows strict conventions, and it's exactly what secures every single available mark.
Part 5, the open loop resolved. Let's talk about evaluative thinking. Remember that examiner clue I teased earlier? Well, here it is. We are escalating now to a much harder concept involving critical analysis, and this is the exact wording examiners use to separate the top-tier students from the rest of the pack. Read this quote carefully. Evaluation requires identifying limitations, assumptions made, and their effect on conclusions. Here is the absolutely crucial insight. Top-scoring candidates don't just calculate, they question assumptions. When you're looking at a kinematics problem, are you just assuming acceleration is constant when the question actually implies it's variable? You must identify these limitations and justify your decisions with hard mathematical evidence. That level of evaluative thinking, that is the master key to the 0606 exam.
0. Literally 0. That is exactly how many marks you are going to get if you execute the math perfectly but fail to contextualize your evidence or present it in the appropriate format. If you ignore the assumptions, if you use the wrong terminology, or if you skip that structural sequence we talked about, it all amounts to 0. You have to prove your analytical depth every single time you put pen to paper. No exceptions.
Finally, part 6, the mandatory next lap.
Okay, so you've got the framework, you know the method mark strategy, you know what the examiners are warning against, and you understand the immense power of evaluative thinking. But just like our F1 race, finishing one lap just means preparing for the next. What happens when the exam throws a disguised question that breaks these exact rules? Knowing the methodology is completely useless if you fall into the common traps hidden within specific, deceptive kinematic questions. These questions are practically designed to make you apply the right framework to the exact wrong scenario. To make absolutely sure that doesn't happen to you, you need the final piece of the puzzle to lock in those grade boundaries. Definitely subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE. We are here to help you excel in your Cambridge examinations, and honestly, it's the absolute best way to ensure you don't miss our critical breakdowns of these highly deceptive questions. In our next explainer, we're going to tear apart those specific common traps by question type in the 0606 syllabus. So I'll leave you with this final thought. When you walk into that exam hall, will you execute a flawless pit stop, or will a hidden examiner trap cost you your grade? I'll see you in the next explainer to make sure it's the former.